The smartwatch production process begins with concept design, where industrial designers and engineers finalize the size, shape, and functions. Most smartwatch factories use computer-aided design (CAD) software to visualize every detail before making physical prototypes. Printed circuit boards, PCBs, are the backbone of a smartwatch, integrating the processor, sensors, memory, and communication modules. PCB manufacturing involves layer stacking, etching, and solder masking for compact yet durable designs. The microprocessor is often sourced from specialized semiconductor manufacturers before being mounted on the PCB. System-on-chip, SoC, technology enables multiple functions, Bluetooth, Wi-Fi, GPS, and heart rate monitoring, on a single tiny chip. Smartwatch screens are typically AMOLED or LCD panels, chosen for their low power consumption and high visibility outdoors. The display is protected with scratch-resistant glass, often Corning Gorilla Glass or sapphire crystal in premium models. Touch sensors are embedded beneath the screen, enabling smooth swipe and tap functionality. The battery is usually a lithium-ion polymer, LiPo, cell, designed to be thin yet powerful enough to last a day or more. Battery manufacturing involves precision layering of electrodes to maximize energy density in a small form. Most smartwatch cases are made from aluminum, stainless steel, or polycarbonate plastic, depending on cost and durability requirements. CNC machines are used to cut and shape metal cases with high precision. Waterproofing is ensured by using rubber gaskets, adhesives, and ultrasonic welding during assembly. The strap production involves silicone molding, leather stitching, or metal link machining for comfort and style. Sensors such as accelerometers, gyroscopes, and heart rate monitors are sourced from specialized suppliers. Optical heart rate sensors use green LED lights and photodiodes to measure blood flow beneath the skin. Advanced models include SpO2 sensors, barometers, and even ECG electrodes for medical-grade monitoring. Wireless modules like Bluetooth and Wi-Fi chips are carefully integrated to maintain connectivity while minimizing power consumption. GPS chips are tested for satellite signal strength inside shielded labs before final assembly.